I'm going to be running through the first 8 questions of our Surds exam questions homework. Question 1, work out 7 over root 2 multiplied by root 3 over root 10. We have to give our answer in the form x root 15 over y, where x and y are both whole numbers. Now, whenever we're looking at this question, alarm bells should be ringing instantly because we've got in our final answer root 15 on the numerator. Now, in the multiplication of the two fractions, we don't really see root 15 anywhere. So what you should be thinking is this question will involve rationalizing the denominator in order to change the root 3 on the numerator to a root 15. But let's simplify the multiplication first and see where we go from there. So when we're multiplying fractions, we multiply numerator by numerator and denominator by the denominator. 7 times root 3 is 7 root 3. And the denominator root 2 multiplied by root 10 is root 20. The next step, which would probably be the easiest thing to do now, is to try and simplify any of the surds we have. We can't simplify the root 3, but we can simplify root 20. So the numerator stays the same. Root 20 can be written as a product of prime factors as 5 times 2 times 2. So we can write this denominator as 5 times 2 times 2. Now if we're going to separate our roots now, we have 7 over root 3 over root 5 times root 2 times root 2. Now the pair of root 2's can combine, and we're going to get that as 7 root 3 over 2 times root 5. Which is equal to 7 over root 3 over 2 root 5. Now that's that perfectly simplified. And now we want our answer in the form x root 15 over y. Now we have to make the numerator have a root 15 in it. However, if we just look to rationalize the denominator here, we want to get rid of the root 5 on the denominator. So to do that, all we have to do is multiply the numerator and denominator by the root that's on the denominator. So we're going to multiply the numerator by root 5 and the denominator by root 5. That should get rid of our surd. Root 5 multiplied by 7 root 3 will become 7 root 15. Now we've got our root 15 present. And 2 root 5 multiplied by root 5 is going to be, well, root 5 times root 5 is 5, times 2 is 10. Here we have an answer where we have x is an integer, 7. We have root 15 present in the numerator, and y is also an integer on the denominator is 10. So that is correct, where x equals 7 and y equals 10. Now they haven't asked us to write what x and y are, they've just asked us to write this, but I'm just writing it on the side so you can see that it does satisfy the conditions the question dictates. Now, question 2. The nth term of a geometric progression is r to the power of n, where r is greater than 0. The second term is 8/9. Work out the third term. We have to give our answer in the form c root 2 over d, where c and d are integers, or whole numbers. So I'm going to write this, the geometric progression nth term on this sheet. So it's r to the power of n. Now we've been given the second term, that's where n equals 2. So when n equals 2, r squared is equal to 8/9. That's been given to us in the question. Now we want to work out what r cubed is, the third term of the geometric progression. What we have to do first is work out what r to the power of 1 is, and then we can work out what r cubed is. All right? So if r squared is equal to 8/9, and r to the power of 1 is equal to, well, we have to ask ourselves, how do we get from r squared to r to the power of 1? We take the square root of both sides of our equation. So r to the power of 1 is equal to the square root of 8/9. Now, to work out what r cubed is we just have to cube the square root of 8/9. So we're going to cube the square root of 8/9. Let's tidy up the square root of 8/9 first. So the square root of 8/9 is equal to the square root of 8 over the square root of 9. We can separate the roots when we're dividing. That is within the laws of surds. The square root of 8 is equal to the square root of 2 times 2 times 2. I've just broken it down into its product of prime factors. And the square root of 9 can be written as 3. Now, the numerator can be written as the square root of 2 times the square root of 2 times the square root of 2 all over 3. And we can pair off our root of 2's to get 2. So that can simplify to 2 root 2 over 3. So that is also equal to r to the 1. We've just simplified the square root of 8 over 9. So now we're going to cube this. R cubed is equal to 2 root 2 over 3 all cubed. So cubing the numerator, you've got 2 cubed is 8, and square root of 2 cubed is the square root of 2 times the square root of 2 times the square root of 2, which is the square root of 8. And 3 cubed is 27. Now, we already know we can simplify the square root of 8 to be 2 root 2, because we've just done it over here. The square root of 8 can be simplified to 2 root 2. So that is going to be equal to 8 multiplied by 2 root 2 all over 27. 8 times 2 root 2 is equal to 16 root 2 over 27. Let's just check the conditions of our question. We have to leave it in the form c root 2 over d. And look, we've got c root 2 over d. So that is finished where c equals 16 and d equals 27. That is correct. Now, question 3. Let's take a new sheet. Question 3. We have work out 2 root 10 times root 80 times root 18, giving our answer as an integer. So the first thing we should do here is simplify all of our surds. So let's do root 10. Can't be simplified, can't know, because it's going to be 5 times 2. So that can't be simplified. Leave root 10 as it is. Root 80. Now 80 is product of prime factors, can be written as 2, 40, 2, 20, 2, 2, and 5. So you've got 2 times 2 times 2 times 2 times 5. So we can write root 80 as these 2's would combine, these 2's would combine. So you get 2 times 2 times root 5, which is 4 root 5. And because we've got root 5 here, we can actually decompose the root 10 to be root 2 times root 5. And then the root of 18 can simplify to 2, 3, 3. So we can write that as the 3's combined to give you 3. So you should have 3 root 2. So all in all, we have root 2 times root 5 times 4 root 5 times 3 root 2. So we would have the root 2's can combine. So let's write this out in a different way. So we have the integers at the start. We got the 4 times by the 3 times by root 2 from here times by root 2 from here times by root 5 from here times by root 5 from here. Now the root 2's pair and the root 5's pair. So you're going to get 4 times 3 is 12 times 2. The two root 2's combining times 5. 2 root 5's combining, which is going to be 24 times by 5, which is going to be 120. Our final answer for question 3, which is an integer. Question 4. So we got a is root 2 and b is root 18. So we want a squared's been done for us. It's the answer is 2. We want to work out what a plus b is. So root 2 plus root 18. 18 can be written as a product of prime factors as 2 times 3 times 3. The 3's would pair to get root 3 times root 3 is 3. So you get root 18 can be written as 3 root 2. So we're actually doing root 2 plus 3 root 2. So we have in total 1 lot of root 2 plus 3 lots of root 2 is 4 root 2. So that is going to be this one here. A times b next. A times b, so that's root 2 times root 18. We can just multiply the numbers under the roots, which is going to be root 36, which is equal to 6. And b over a finally, root 18 over root 2. We can just divide the numbers under the roots, and that's going to be root 9, which we all know to be 3. So that is going to be 3 up here. Question 5. The root 150 minus root 6 over root 2 times root 3. So let's firstly do the product of prime factors of 150. It's 2 times 5 times 15, or sorry, root 2 times 5 times 5 times 3. Now, we can then write the root of 150 as the root of 2 times the root of 5 times the root of 5 times the root of 3 minus root 6 over root 2 times root 3 is root 6. Tidying this up, we can pair up the root 5's. So that next line is going to be 5. Root 2 times root 3 is root 6 minus root 6 over root 6. 5 lots of root 6 take away 1 lot of root 6 is 4 root 6 over root 6. The root 6's cancel and you're left with 4. Question 6, we've got root of 80 plus 2 and 2/9, root of 2 and 2/9. So this is an interesting question. What you have to do firstly, we've got a mixed number here and we want to change that into an improper fraction. So 2 and 2/9 is going to be equal to, there's 9 parts in the fraction, so 2 wholes would have 18 parts, plus the extra 2 parts are going to be 20 over 9. So let's write that in. So we've got root of 80 plus the root of 20 over 9. Now, let's see if we can tidy this up. So, we've got the root of 80. Right, 80 is its product of prime factors. 80 is going to be 2 times 2 times 2 times 2 times 5. There's 2 pairs of 2s, so that's going to be 2 times 2 times root 5. It's going to be 4 root 5. Plus, now, the root of 20 can be simplified. We already know here because we've broken it as part of the decomposition of 80. The root of 20 can be written as the root 2 times root 2 times root 5. So, root 20 can be written as 2 root 5. And root 9 as 3. Now, we have a fraction and a multiplication. However, we need to make the denominator the same so we can combine these two terms. So, if we turn this into a fraction, we have 4 root 5 over 1. Multiply the numerator and denominator by 3. So that's going to be the same as 12 root 5 over 3 plus 2 root 5 over 3. And then we can add these two terms now because we got the same number on the denominator. So 12 root 5 plus 2 root 5 is 14 root 5 over 3. And that's our final answer, where we have in the form a root 5 over b, where a is 14 and b is 3. We got to multiply by root 5 on the numerator. Now, question 7, we are showing that the left-hand side, root 3 plus root 75, all squared, is equal to 108. So to show that question, what you have to do is pick one of the sides and show that it equals the other side. So we're going to obviously pick the left-hand side because it can be simplified, and we're going to show that it equals the right-hand side. So we start off with root 3 plus root 75 all squared. Let's see if we can simplify root 75. So the product of prime factors of 75 is 5, 5, and 3. So 75 can be written as, the root of 75 can be written as root 5 times root 5 times root 3. 5's pair, and we get 5 root 3. So if root 75 can be written as 5 root 3, you're going to have root 3 plus 5 root 3 all squared, and that can be written as 1 lot of root 3 plus 5 lots of root 3 is 6 root 3 squared, all squared. And then all we have to do is square the integer and square the surd. So squaring 6 is 36. Squaring the root 3 is 3. So it's 36 times 3. 36 times 3 is 108. And therefore, the left-hand side equals the right-hand side. And we've solved it. Last question. Simplify fully the root of 72. That's quite nice. All we have to do is do prime factors of 72. It's going to be 2, 2, 2, 3, and 3. So we've got a pair of 2's and a pair of 3's and one left over 2. So 2 times 3 is 6. That's going to be 6, 2. And part B, given that P equals root 3, Q equals root 8, and R equals root 6, what is PQ over R? So we're doing P, which is root 3, multiplied by Q, which is root 8, all over R, which is root 6. So that's going to be root 3 times root 8 is root 24 over root 6. And when we're dividing surds, we can just divide the numbers under the roots. So 24 divided by 6 is 4. And we're going to get root 4 as the answer, which simplifies to 2. And that is questions 1 to 8.